Okay, in this session, we'll continue our discussion of generative functions. So before we start the discussion on generating function, we'll have a useful tool which is called Binomial Theorem, which will actually help us in finding the closed forms of many generating functions. Okay, so we all have already done the Binomial Theorem. We have done our combinatorics course. Okay, so what is the Binomial Theorem? So if a and b are two numbers, and if you have to find a plus b raised to n, where n is a positive integer, okay, the value of this is simply nc0 a raised to n plus nc1 a raised to n minus 1 b plus nc2 a raised to n minus 2 b square plus etc plus ncn b raised to n. Or in particular, if it is actually 1 plus x the whole raised to n, it will be simply be nc0 plus nc1 x plus nc2 x square plus etc plus ncn x raised to n. Okay, so where here n is a positive integer. Now we will extend this binomial theorem for powers which are other than positive integers. Okay, so suppose we are taking, so basically this is our starting point, which is 1 plus x raised to n. Okay, so this is our starting point, so it is nc0 then plus nc1 x plus nc2 x square plus etc plus ncn x raised to n. So we'll discuss about powers which are other than this positive integer. So we'll be considering any real number. So n can be any real number. So we'll be considering what is the value of this 1 plus x raised to n. So in that case, actually, instead of getting a finite polynomial, your answer will always be an infinite series. Okay, so when it is any other real number other than a positive integer, always you will be getting an infinite series, and hence you will be getting an infinite generating function. Okay, so we'll discuss how to write that function series first. So first let us try to understand what do you mean by NCR. Okay, NCR is nothing but so when it is for positive integers, it is well defined. It is actually defined as n factorial by n minus r factorial into r factorial. So let us try to write down this more explicitly. So it is actually n into n minus 1 into n minus 2 into, you can see that these terms are being successively reduced. So it will reach a point where n minus r minus 1 would be there. Okay, then you will have n minus r would be there. Okay, then what will be the next term? Can I just guess? So it will be next term would be n minus r plus 1 would be there. Okay, so it will go till 1. Actually the 1 is obtained by n minus n using this term actually. Okay, so successively the terms are being decreased in n factorial. The whole divided by, when you take n minus r factorial, it will start with n minus r. The next term would be n minus again r minus 1. Okay, so it is actually n minus r minus 1, then it would be n minus r minus 2 etc up till 1, and then you have the r factorial here. You can see that this n minus so n minus r, you can cancel this n minus r, you can cancel out n minus r minus 1 will go out there. Then there will be n minus r plus 2 in brackets there. So these terms would get cancelled out. So ultimately the value of this factor of NCR is nothing but it is actually n into n minus 1 into etc up till n minus r minus 1, okay, divided by r factorial. Or in other words, so if I take out these brackets, it is nothing but n into n minus 1 etc n minus r plus 1, okay, divided by r factorial. So this is the value of NCR when you try to expand it in definitions of factorial. So this is how we are going to define NCR for any real number n. Okay, so if n is any real number, okay, so I am going to define NCR in the same format is defined as n into n minus 1 into etc n minus r plus 1 divided by r factorial. R factorial is always defined because r is always an positive integer only, so there is no issue here. And in particular, if it is nc0, we will just assign the value of this as simply 1. So nc0 is simply defined as 1. So let us try to understand what is 3 by 2 c5. So can you just write down what is 3 by 2 c5? It is nothing but it is 3 by 2 into 3 by 2 minus 1. Okay, up till how much you should write? You should write till 3 by 2 minus 5 plus 1, that is actually up till 3 by 2 minus 4 you should write. So the value will be 3 by 2 minus 2 into 3 by 2 minus 3 into 3 by 2 minus 4 divided by 4 factorial. Okay, so if you have understood the definition of NCR for this symbol for any real number. Let us now try to write a definition of what is the expansion of 1 plus x raised to n, where n is actually a real number. So it is nothing but it will be 1 plus again n into x plus again n into n minus 1 by 2 factorial into x square. This is actually the term corresponding to nc2. This is a term corresponding to nc1. Okay, the next term, can you just guess what is it? It's nothing but n into n minus 1 into n minus 2 by 3 factorial into x cube, plus it will go like that. This is the term corresponding to nc3, and for the r term would be n into n minus 1 into n minus 2 and etc. n minus r plus 1 by r factorial into x raised to r. So you have to be very careful. This would be the r term. So in most problems involving the generating function, you will have to find the coefficient of x raised to r. So this is actually the coefficient of x raised to r. So you can note it down. Okay, so that is the term. So it will go on indefinitely like an infinite series. Okay, so let me recap here. The coefficient of x raised to r is actually given by n into n minus 1 into etc. n minus r plus 1 divided by r factorial. Okay, now what's the case when if n is a negative integer? Okay, so suppose I need to find 1 plus x raised to minus 4 or 1 minus x raised to minus 5 etc. So what is n? If what will be the case if n is a negative integer? Then also when you take this x of it is minus n. Okay, suppose it is this, then also when you define it, it will be like the same thing. It will be minus n into minus n minus 1. Okay, so you just apply the definition here, etc etc. It will go till next term would be minus n minus 2. Okay, it will go till minus n minus r plus 1, just like definition for any real number divided by r factorial. So if you take the minus outside, how many minus signs would be there? So when you take the first two terms, when it is minus n minus 1, you will have 2 minus signs. In this minus n minus 2, it will be 3 minus signs. So when it is minus sign minus r plus 1, this is actually minus n minus of r minus 1. So when you take that, you will have actually r minus sign. So when you take it out, it is actually minus 1 raised to r. I hope you can understand. Only if you write with me, you will understand how it is obtained. Into n plus 1 into n plus 2 into etc. You take the minus sign outside here. The last term would be simply n plus r minus 1. Okay, so n plus r minus 1 divided by r factorial. I can even rewrite this term in terms of factorials. So you can see that this is actually n plus r minus 1 is there, n plus r minus 2 would be there, n plus 2 would be there, n plus 1 would be there. So till n is there. So if I introduce n minus 1 factorial, okay, so in the numerator and denominator, what will I get? We will be getting it as minus 1 raised to r, n plus r minus 1 factorial, okay, n plus r minus 1 factorial divided by r factorial into n minus 1 factorial, or in other words, this is nothing but minus 1 raised to r, n plus r minus 1 c r. Okay, so how is it obtained? You can simply just try to compute this value. What is it? It's nothing but n plus r minus 1 factorial according to definition divided by n plus r minus 1 minus r factorial into r factorial. This is nothing but n minus 1 factorial. So actually you are getting it as n plus r minus 1 CR. So only if you write down with me, you will understand how it is obtained. So we have obtained a new result. It's a very important result. The value of minus n CR when n is a negative integer is nothing but minus 1 raised to r n plus r minus 1 CR. So this result is very important. You will be using this in applications. So let us try to understand this result by means of few examples. Okay, suppose I need to find maybe minus 8c5. So how will you find it? It's nothing but minus 1 raised to 5 into n is 8, r is 5. So 8 plus 5 minus 1 c5, it is 13 minus, so it is minus 1 raised to 5. Okay, 13 minus 1, 12c5. Okay, so similarly if I need to find minus 16c10, how will you find it? It is nothing but minus 1 raised to 10, then 16 plus 10, 26, minus 1, so it is 25 25 c10. Okay, so I hope you understand how to compute the terms here. Okay, so when you are considering 1 plus x raised to minus n, it is nothing but minus nc0 plus minus nc1 x plus minus nc2 x square, etc. The rth term would be simply minus ncr x raised to r plus etc. Okay, and this minus ncr, the value of this is actually minus 1 raised to r n plus r minus 1 cr. Okay, so this is a special case of the general case when 1 plus x raised to n, where n is in a real number. So the general formula is nothing but 1 plus nx plus n into n minus 1 by 2 factorial into x square plus etc. So if you want to remember, you can just remember the general formula. There is no need for this sub case, but still I have introduced to you because sometimes when you define this using sub case, it will be easier to compute that, or you can straight away use the generic formula, which is 1 plus nx plus n into n minus 1 by 2 factorial into x square plus etc. So this is the extension of binomial theorem, and now we'll see how these type of ideas are being applied in our problems. Okay, so let us try to understand how these problems are being applied in our generating function. This is the discussion which we had till now. We had a discussion till this. Okay, so everything is there. So the formula is being given here. Okay, so this is the expansion which we have already discussed. This is expansion. This is also there in your textbook. You can see the textbook for the expansion. Okay, and for the negative integers also we are seeing this expansion. Okay, so just remember these things. So now we will try to understand some problems. So before we move on to these problems, let us try to find some generating functions. Okay. Okay. So let us try to do these problems here. These are straight away from your textbook. Okay. So here I am actually giving you some sequences. You need to find their generating functions. Okay. Okay. So first the sequence, please consider 8c1 plus 8c2 plus 8c0 plus 8c1 plus 8c2 plus etc. So how will you do this? Okay, so first of all, you just write down the generating function. What is it? It's nothing but 8c0 plus 8c1 x plus 8c2 x square plus etc. plus 8c8 x raised to 8. Okay. Now can you tell me what is the close? So this is the generating function. Can you tell me what's the closed form of this? So if you remember the binomial theorem, it is nothing but 1 plus x the whole raised to 8. Okay, so that's the first question. Now see the second question. Just write down 8c1, 2 8c2, 3 8c3. So how will you write it? First let us write down the generating function, which is nothing but 8c1 plus 2 8c2 x plus again 3 8c3 x square plus etc. plus 8. So when it is 8c3, you are getting x square. So when it is 8 into 8c8, it will be simply x raised to 7. Okay, now this is the generating function. Now how will you write the closed form? If you just see the first problem, you can see that they are actually differentiating the polynomial there. Okay, so when they differentiate, you are getting h1 here. When you differentiate this, you are getting 8c into x 2x here. So this is the derivative of this polynomial. Hence the closed form of generating function of this sequence would be basically the derivative of this one, which is nothing but 8 into 1 plus x raised to 7. Okay, so that is also done. Now let us look at the third problem. It is again 1 minus 1, 1 minus 1 etc. We have done this problem earlier. We already know it. What is it? It's basically 1. It is basically 1 minus x plus x square minus x cube, alternatingly plus and negative sign. So it is nothing but 1 by 1 plus x. Okay, so when this so this is the closed form of that. Okay, now look at the next problem also. First of all, when you get a problem, try to write down the generating function first as an infinite series. Okay, then you will understand the idea how to do it. So look at the next question. The first three terms are 0, so the terms corresponding to 1 is 0, x is 0, x square is 0. So it is starting with 6x cube minus 6x raised to 4, okay, plus 6x raised to 5, etc. So you can take this 6x cube outside. So it will be simply 1 minus x plus x square minus x cube, etc. So what is the closed form of this thing? This is we have discussed already. It is nothing but 6x cube into 1 by 1 plus x. Okay, so that is the closed form of that series. Now look at the next one also. That also is very simple. It is nothing but 1 0, all it is alternating ones and zeros. So basically the sequence was simply, it was 1 0 1 0 1. So just write on this 1 plus x square plus x raised to 4 plus etc. Similar to our 1 plus x square etc. The value of this one was 1 by 1 minus x. So looking at observing that, you can see that the value of this one would be 1 minus 1 minus x square. Okay, so that's the last problem, and one more problem is there, that also you can try it yourself. So what is the question there? Just observe the question. It is a new series. It is given as say 0 0 1. So the term corresponding to 1 is 0, x is 0, x square is there, so it will start with x square plus ax cube plus a square x raised to 4 etc. So you can take this x square outside, you will get as 1 plus ax plus a square x square plus etc. Just think what is the value of that. You have already discussed that thing. It is nothing but x square into 1 by 1 minus ax. Okay, so these are all obtained from your knowledge of infinite series and also the binomial theorem, and we have also discussed some standard series. So that is the idea there. Okay, now let us try to understand the next type of problems. Here you are being asked to find the corresponding sequence generated by these functions. It is very easy. So the first one is 2x minus 3 whole cube. Just write down the binomial theorem for that. What is it? It is nothing but 3c0 2x the whole cube plus 3c1, okay, 2x the whole square into minus 3, okay, then 3c2 into 2x into minus 3 square, then finally 3c3 when 2x is over minus 3 the whole cube. Okay, just write down the binomial theorem and you just simplify this result. The next question is x raised to 4 by 1 minus x. So x raised to 4, 1 by 1 minus x, I already know the expansion, it is 1 plus x square plus etc. So this is the corresponding sequence. So it will be actually x raised to 4 plus x raised to 5 plus x raised to 6. So the corresponding sequence would be, the first term is 0, corresponding to 1 is 0, again x is 0, x square is 0, x cube is 0, again everything else is simply 1. Okay, in the first one, the series, the sequence, when you simplify, you will get the sequence as 3c0 into 8, then second term would be 3c1 into 4 into minus 3, so it is minus 12 would be there. The next one would be 3c2 into 2 into minus 9, again minus 18 would be there. So you can find that series. Okay, now look at this third problem, C. What is it? X cube by 1 minus x square. Please do it yourself. So how will you find it? It is x cube by 1 minus x square. The corresponding sequence would be x cube plus 1 plus x square plus x raised to 4 plus x raised to 6 etc. So the value is x cube plus x raised to 5 plus x raised to 7 plus etc. So series would be, the term corresponding to 1 is 0, term corresponding to x is 0, x square is 0, x cube is there, again x raised to 4 is 0, x raised to 5 is there, x raised to 6 is 0, x raised to 7. So this is the corresponding sequence. Okay, similarly you can find the value of f of x of 1 by 3 minus x. You just take the 3 outside and make it in the form 1 by 1 minus something. So it is actually 1 by 3 minus x. If you take 1 by 3 outside, it is 1 minus x by 3. So that is 1 by 3 into 1 plus x by 3 plus x by 3 the whole square plus etc. What would be the corresponding sequence? It would be 1 by 3, then 1 by 9, okay, then 1 by 3 into 3 square, etc. etc. So this also you can accordingly give the value of 1 minus x, and you collect the terms and then just generate the series. And similarly you can do the rest of the problems also. Okay, so that's it. We will discuss more about generating functions in the coming lecture also. Thank you.